Hi, in this lesson, we're going to look at storing objects and method overloading. In the last lesson, we learned that we can create new objects for a class using a class constructor. We also learned that the actual parameters that are input into the constructor must also match the total number of parameters that are found in the constructor, otherwise there will be an error. But we can actually get this constructor call to work if we create an additional constructor that only accepts one parameter. We can create additional constructors to improve the flexibility and functionality of our programs. Suppose a developer wanted to create squares using the rectangle class. We can give them the option to create a rectangle object that only takes one parameter to indicate that all sides of the rectangle should be the same length. We can add additional constructors that will take a different number of parameters. When the call to constructor rectangle 16 is used, Java will look for the constructor call with the appropriate number and type of parameters and use that constructor. Having multiple constructors with the same name but different formal parameters is called overloading. The compiler knows which constructor to use based on the signature list of the parameters that are passed. We can also write constructors that don't take any parameters at all. In this case, we can write the constructor with empty parentheses, which will create the rectangle object with the width and height values predetermined. This might be useful if we were planning on creating a lot of 10 by 10 rectangles and didn't want to have to write the parameters out every time we created a new rectangle object. This table demonstrates the different ways that the constructor can be called in real time. For each of these examples, the value of width and height are determined by the formal parameters or lack thereof. In the creation of the rectangle class, we can choose to create one of these or add all of them to our class to allow multiple ways of creating a new rectangle object. When we instantiate objects, we are creating a reference to where the actual object data is located. Rect points to where the values of width and height, which are stored in primitive variable types, exist in memory. But when an object has not been instantiated, it isn't pointing to any particular object data. When that happens, the object, in this case rect, is considered to be a null object. Null is a keyword value that indicates that a reference object does not point to any data. This can be used to help find errors in code and to indicate that an object isn't being referenced appropriately. Not only can we create our own classes, but we can take advantage of the ones that have been created by others. We can use existing classes and libraries so we aren't required to reinvent the wheel. The scanner class is a great example of one we have already learned to utilize. When we use a class like scanner that someone else has created, we are considered a client of that class. As you can see, the constructor for scanner looks similar to the one we put together for rectangle. When we created a new scanner, we were instantiating a new scanner object that we could then use to read text that is input to the console. The class name scanner is identifying the class type for the variable input and is being instantiated by the keyword new. The formal parameter for scanner is an input stream, and the actual parameter that we are using is system.in. There are numerous other examples of classes that we can implement, and we will continue to learn about them over the course of this unit. Now that you've learned about method overloading, let's get some practice in the CodeHS editor.